Okay, year 11, I'm going to do a video that's going to cover the next couple of exercises, 502 and 503. And I've got our website up. Remember that the website has the board work from the previous year, so you can access that as well. And I also want to point out something else that I put on the website recently this morning. And also that's a very good one. That video there from the University of New South Wales is about Plimpton 322. It's really quick, so I recommend you have a watch of that. But here is a video that I've put up from Stuart Palmer. He used to be the head teacher at PLC and was on the Maths Association of New South Wales, and does a lot of PD for teachers teaching advanced extension, standard, extension 2. And here he's got a nice little video, and it goes for 7 or so minutes, about the reference sheet. And I highly recommend you watch that, take whatever you need from it and have a look at it. And really, while you're doing that, have your reference sheet there and make some annotations. The reason I'm starting with that is because I want to talk about the reference sheet in regard to what it provides us with trigonometry. So before we begin our work today, I'm going to have a look at that. So here is the reference sheet. And remember, you should download that from the Board of Studies. This is a 2020 reference sheet. It may change, and if they do, we'll make sure if there are any changes, we make sure that we have a look at them. So the first page is there. I want to look at the second page in trigonometry. And remember that your reference sheet that you have within your folder is something that you need to annotate and make sure that you are constantly looking at it so you know what you need. So for us in advanced mathematics, that's all we need. This bit here, all this bit, and Mr. Palmer in his video talks about this, all of this is extension 1. You do not need it. All of that bit. You can cross it out, or you can just write extension 1. It's stuff that you don't need to know as an advanced student. This is all you need, or this is all the reference sheet gives you in regard to trigonometry that is covered in your course, so the advanced course. There are some things there that you should remember. I'm going to talk about, so here we get sine, cos, and tan, and they've used the abbreviations op, hyp, ag, and you should know what those are. Here are these 2 right-angled triangles that I did a video on previously that you need to probably have a look at. And here are our 3 rules, our area rule, our sine rule, and our cosine rule in 2 versions. These 2 rules here relate to a thing called radian measure that we're going to do later on. Here are our reciprocal ratios for sine and cos. That one's for cos and that one's for sine, and you can see. And this is very important here, and we're going to talk about that, and I'm going to do it really quickly over here. Because this is cot. Cot, remember, is a reciprocal of tan. But notice how they've given it to us. They've given it to us in cos and sine, which gives us another really beneficial thing. So over here, I'm going to draw a little triangle. So if I have a right angle triangle, I'm going to explain where this comes from. And I'm just going to call this theta. I'm going to call this A, B, and C. And I'm going to go, so sine theta equals opposite. Well, that's B over hypotenuse, which is C. I'm going to put my right angle in. And cos theta equals adjacent A over C. Now that's right in any triangle because I've used algebra, it doesn't matter. And tan, we know, is opposite over adjacent, which is B over A. Now watch what happens here. If I take sine theta over cos theta, and I write that, well, what's that? Well, we already said sine theta is B over C. So B over C, and cos theta is A over C. Oh, what do we do when we divide by a fraction? Well, we multiply by the reciprocal. All right, see, I've turned that bottom fraction upside down. And straight away you can see that the C's will cancel, leaving me with B over A. And we already know that that's tan theta. So here's a very useful thing, and they don't give it on the formula sheet, which I wish they did. Tan theta can be written in terms of sine theta over cos theta. Now, they don't give you that. They don't give you that. It's really useful, particularly when we do trig identities. And that's what this is all about, trig identities. But they do give it to you in a way, because here they tell you that cot theta. Now remember that cot theta is just the reciprocal of tan theta. So if you turn that upside down, if you turn this expression, or this bit upside down, you get tan theta, which is sine over cos, which I just proved to you. So that's really useful when we come to trig identities. They're the things you need to know and be able to use. Don't worry about some of it yet. We haven't come across it, but when we do, I'll go over it again. So let's have a look at trigonometry now in terms of what we have to do. So I'm going to do 502 and 503 in this video. So it's going to be a bit of a long one, but I'm only going to do 3 examples, and then you can have a go yourself and send me questions. So in trigonometry, I have 3 rules to solve any trigonometry problems, solving trig problems. I have a 3-step procedure. 1, you've got to pick the right ratio. You've got to be good at going, all right, what do I need? Do I need sine? Do I need cosine? Do I need tan? And you've got to be able to pick the right ratio. And you've got to look at the information you're given, or the diagram that you've been given, and make sure you pick the right ratio. So that's step number 1. Step number 2, you write an equation, because that's what it is. It is an equation. You are going to write an equation. And then step 3, you solve that equation. Solve it. Now, essentially, they can only ask you 3 problems. They can ask you to find a side or find an angle. But you say to yourself, that's only 2. When they ask you to find a side, they can ask you to find a side with the pronumeral underneath, where the unknown is underneath, or the pronumeral is on top. And we're going to do 3 examples of these. So, what can they ask you? Well, we'll do a side first. Finding, and this is just for right angle trigonometry, finding a side. Well, finding a side, we'll do a nice easy one first, with the pronumeral on top. That just means in the numerator. And I want you to just remember, when the pronumeral's on top, you multiply. So let's have a go at one. So we'll find one down here. And look, let's just do the first one here. So first, this is 1A. The first thing I'm going to do is pick the right ratio. Well, I've got this angle. I've got this side that I've got to find, and this side. Well, I've got the opposite and the hypotenuse, so I'm going to choose sine. So I've picked the right ratio, and I'm going to write an equation. Sine of the angle, and it's 31 degrees and 43 minutes, equals x opposite over 12. Now, please remember, this is a number. All right, you can go to your calculator and you're going to type in sine 31 degrees 43 minutes. And that's what it is. That's what that number is, 0.52571911198. And it probably goes on. The reason I want to emphasize that is because if this is a number, so imagine if you had the equation 4 equals x over 2. You just go, oh, I'll multiply that 2 across and I'll get x equals 8 or 8 equals x. That's exactly what you're going to do here. It's exactly the same thing. So I'm going to multiply that 12 across. I'm going to go 12 times sine 31 degrees, 43 minutes. And that is the most important line of your working because you're showing that you know what you're doing. And then you just jump to your calculator and go 12 times sine 31 degrees and 43 minutes. What do we get? 6.31 equals x. Let's just check what the measurements all were in. They don't tell us. They tell us to go to one decimal place. We've done that. So there we go. We double check, make sure. I've just got the answers up here. 6.3. Oh, they want one decimal place, so it's 6.3. So there's our first one. Finding a side with the pronumeral on top, you multiply. Okay. What about the pronumeral, which is the unknown side, underneath in the denominator? Well, if the pronumeral is in the denominator, we're going to divide. But remember, order is important when you divide. So let's find a question here. B is going to be the pronumeral on top. 10, that over that, that's going to be pronumeral on top. I bet they come up in the second question. Yeah, that's a pronumeral. They're all pronumerals on top. 10, that opposite. Here we go. I'm not sure about that angle there, so I might find another one where I can see it. Opposite over adjacent, opposite over. Aha, here we go. Here's one here that's going to have the pronumeral underneath. So let's do our steps again. So this is 1R. Assume it's 1R. Yep. 1R. Actually, I'm going to do P because R is going to be sine, and I want to do one that's not sine. So I'm going to do P. Now, when I do this one, I pick the right ratio. Now, I've already given you a hint. It's not sine. What could it be? Well, I've got the adjacent side, and I have the hypotenuse. So cosine. So cosine, a lot of people say cos. Write the angle, 46 degrees and 5 minutes equals adjacent, so 14.3 over K. Now, I'm going to show you something here. If you have 7 equals 3 over K, essentially, that 7 and that K are going to swap spaces. I'm going to show you why. Once you've done this, you don't have to do it anymore. You can just go straight to it. So I'm going to multiply by K. And remember, K is, even though it's a number, it's a number we don't know. We can treat it like a number. So I multiply the K across. So I get 7 times K equals 3. And then I'm going to divide by the 7. And as you can see, the K and the 7 have magically swapped spots. I'm going to do the same thing here because that's a number and that's a number. And the K and the cos 46 degrees 5 are going to swap spots. So you can go straight to this line. K equals 14.3 divided by cos 46 degrees 5 minutes. Now you can actually write the middle step in where you've multiplied by k, then you've divided by cos, or you can go straight to this position. And then it's just a case of 14.3 divided by, I like to use brackets, although I don't think it makes any difference in this case, cos 46 degrees and 5 minutes. 20.6, and I'll just better check because I don't want to make a mistake. This is P, 20.616, my only go into, so equals 20.6, which is correct. So, when they ask you a question, any trig, right angle trig, pick the right ratio, write an equation, and then solve it. If they ask you to find a side and the pronumeral's on top, you're going to multiply. And if the pronumeral is underneath, you're going to divide. What about finding an angle? This is the easiest step. If you've got to find an angle, you just inverse sine, cosine, or tangent. And the inverse is just given by the -1. It's a terrible symbol, I know, but anyway. So we have to go to the next exercise. So I'm going to scroll down to there. I'm going to choose one of these ones. And I'm going to try and find a tan, and luck should have it. This one is a tan. So, same steps. Number 1, so this is 1A, 503. Write an equation. Well, first I have to pick the right ratio. I've already told you, I've got opposite and I've got adjacent. I don't have the hypotenuse. So I'm going to choose tangent. Tan, what's the angle? X equals opposite 5/6. Now remember that this is an operator. It's like square rooting, it's like multiplying or dividing. And to undo it, to get the pronumeral by itself, because that's what we're going to do now, because this is an equation and we need to solve it, we have to undo tan. And the way to undo tan is inverse tan. So X equals inverse tan. And if you go to America or other countries, they sometimes call it arctan. Now it's important to make sure you put it in parentheses. And then you just go to your calculator and we go inverse tan, 5 divided by 6. Luckily our calculator keeps the parentheses there. You can write it as a fraction, you can write 5 divided by 6. You get that, 39.8 ... 39.8, which is a decimal, but they want it in degrees and minutes. So I get my calculator and I hit my degrees and minutes button. 39 degrees, 48 minutes, 20 seconds. 39 degrees, and it's good to do this, 48 minutes and 20 seconds. They want us to round off to the nearest minute. So this is why this rounding off in the last exercise was important. 39 degrees. Is the number behind there 30 or more? No. Leave it as 48. And again, I'll just double check and we're right. So, my 3 steps for doing these questions. And you can write your own notes, but I'd suggest writing something similar. Pick the right ratio. It's crucial. Write an equation. Always write the equation so that even if you get it wrong after that, you can get some marks for showing some understanding of how you solve a right angle trig question. And then you solve it by either multiplying the number across, dividing by the number, or inverse sine, cos, or tan. All right, good luck.